We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello dear friends, myself is Roshani Parikh and today we are going to learn about the star to delta transformation. Now in a previous lecture we have studied the delta to star transformation. Suppose if you want to refer, then go to the YouTube inbox and search for the delta to star transformation by Roshani Parikh and you will get the video and you can see. Now today we are going to learn star to delta transformation. Now star network, that is the Y network. How to convert the star network into its equivalent delta network. Sometimes it is necessary to convert the star into its equivalent delta network for the simplifying the circuit or a simplifying the calculation or a simplifying the network. Now see, here a one star network is a given which is drawn by the blue diagram. Now star network having a 3 terminal 1, 2 and 3 and having a 3 resistance which is labeled as a R1, R2 and R3. You can label as a any name like a RA, RB, RC. Here I have labeled as a R1, R2 and R3. Now how can we convert this star network into its equivalent delta network? So it's a very simple formula. See, connect all the 3 terminal of the star from the outside. Connect all the 3 terminal of the star from the outside, then you will finally get a one network which is drawn by the dotted black diagram. So it seems like a triangle. It is a delta network. So finally you will get the delta. Now see, the link which you are getting by connecting the R1 and R2, that is labeled as a R12. The resistance of the link which is getting by connecting the terminal 1 and 2 from the outside, so it is labeled as a R12. So here a label as a R12. Same way, the resistance of the link which will you get by connecting the terminal 2 and 3, that is labeled as a R23. So here R23 which is the terminal from 2 and 3, between a terminal 2 and 3. Same way, the resistance of the link which will be finally connection from the terminal number 1 and 3, that is the R13. So here the delta equivalent resistances are there. Now how can you find out the value of a delta connection resistances? Now see, R12, that is the resistance of link which will be resultant from the connection of the 1 and 2. तो R12 हमें कैसे मिलेगा? तो R12 मतलब हमें R1 और R2 रेजिस्टेंस को कनेक्ट करते हैं आउटसाइड से और जो हमें लिंक मिलती है उसका रेजिस्टेंस है. तो R12 that is the algebraic sum of R1 and R2 plus multiplication of both resistances divided by the resistance of its opposite branch. ये लिंक का opposite branch है, उसके resistance डिनोमिनेटर में लेना है. तो R12 is equal to summation of R1 plus R2 plus multiplication of both resistance R1 R2 divided by resistance of opposite branch, that is the R3. Same way you can find out the R23 is equal to R2 plus R3 प्लस R2 डिवाइडेड बाय इसका अपोजिट ब्रांच का रेजिस्टेंस कौन सा है? R1, तो उससे डिनोमिनेटर में ले लो. सेम वे R13 इज इक्वल टू सबमेशन ऑफ रेजिस्टेंस R1 प्लस R3 प्लस मल्टीप्लीकेशन ऑफ बोथ रेजिस्टेंस R1 R3 डिवाइडेड बाय उसके अपोजिट ब्रांच का रेजिस्टेंस कौन सा है? R2, उससे डिवाइड करो. तो दिस वे यू कैन फाइंड आउट द वैल्यू फॉर द डेल्टा कनेक्शन और फॉर द डेल्टा नेटवर्क. नाउ दिस वे यू कैन इजीली कन्वर्ट एनी स्टार नेटवर्क इनटू इट्स इक्विवेलेंट डेल्टा नेटवर्क.